Hello guys, Winston here. I haven't run a job on my Shapeoko in quite a few weeks, and that's because I've been busy putting together an enclosure to contain all of the dust that the process of milling generates. Before I explain how I built my enclosure though, I want to talk about some of the design decisions I made and the alternatives I considered. Let's talk about what I didn't do first. I know I could have simply put together a dust shoe and called it a day, but I like having visual confirmation of what my end mill is doing, and most dust shoes obscure everything that happens in the immediate vicinity of the end mill. And even though I've seen dust shoes with a base material of clear acrylic, they're still pretty annoying if you're trying to document a project in still images or videos. Now if your goal is to simply put up 4 walls and a ceiling around your CNC, there are far easier ways than assembling a heavy wooden frame like I did. One of the easiest materials to build a frame out of is PVC. Just buy a couple lengths of 1/2 inch PVC, cut them to the necessary lengths, and assemble them with the appropriate assortment of joints. Then you can just drill a couple holes in the frame and bolt on some panels. The downside to this is that your PVC skeleton won't have a lot of structural strength. You can't put very much on top of your enclosure, and I personally wouldn't transport my Shapeoko in one. My goal was to create a self-contained CNC setup that I could move to different locations in the house, like the garage, or even to a friend's house for collaborative projects. On the opposite end of the price spectrum are things like 80/20 frames. These are almost as easy to put together as PVC and reasonably strong, but the price per linear foot of material is much higher. Still, this will probably give you the best looking and most usable enclosure of all the options out there. Since I really wanted to keep my total costs down, I opted for a wooden enclosure. With the right choice of lumber, I could make something strong enough to transport my Shapeoko in, dense enough to avoid amplifying noise, and flexible enough to accessorize later. I selected 1/2 inch plywood as the base for my enclosure, 1x3s for the frame, 1/4 inch plywood for the opaque panels, and 0.09 inch thick acrylic sheets for the windows. Now since I'm a total woodworking noob, pocket screws were out of the question. I assembled my frame by cutting 4-inch long blocks from my 1x3s and slapping them on with screws like a poor man's gusset plate. I was working on a sheet of MDF to maximize the probability that everything would be put together flat. After building 2 rectangular frames, I joined them with some cross pieces that were 28 inches long. Thankfully, I got everything close enough to perpendicular that all the pieces fit together nicely. The lower cross pieces are 3/4 inch square dowels, which are short enough that they won't interfere with any overhanging pieces of stock material. I sized everything so that the plexiglass viewports I bought would overlap the wooden frame by about 1/2 inch on each side. I planned on attaching them to the frame using a combination of indexing pins and magnets. In order to do this though, I needed to add some structure to the acrylic sheets. I attached a wooden frame to the front and back windows and bored out holes for the bolts and magnets. The front panel also received handles for ease of removal. To attach the frame to the baseboard, I flipped everything over and threw a bunch of screws at the problem. The frame incidentally helped straighten out the plywood, which was slightly warped. Earlier, I'd cut out some handles in the 1/2 inch plywood to make the enclosure easier to pick up. I used a rounding bit to finish off the edges. In order to make my CNC a self-contained unit, I needed to include the Arduino and the G-Shield with the enclosure. To keep them clean, however, I decided to attach them to the outside of the box. I printed out an Arduino PCB template to help me drill the mounting holes in the correct location. I also mounted a power strip and the G-Shield power supply to the baseboard, which was intentionally installed off-center to provide some horizontal real estate. I added an LED strip to brighten up the interior since a lot of the ambient light had been blocked off by the wooden panels. I selected a product that was listed as waterproof to make sure that all of the electrical contacts would be shielded from dust. Although I thought about installing acoustic tiles in my enclosure, the fact that I had so many thin acrylic panels would have negated such an effort. But while the enclosure doesn't really reduce the amplitude of the noise generated by my Dremel, it does change the character of the noise. Instead of a single high-pitched whine, the sound is muffled and spread out across lower frequencies so that it's a little less annoying. With a naturally quiet spindle, I could envision using this setup somewhere like an apartment. Unfortunately, I can't do anything about the other major source of noise related to my CNC operations, the vacuum. Even though my enclosure will trap most of the dust generated during milling, I'd rather not have it settle on the belts and rails or be recirculated into the motor of my Dremel. So I'm still going to employ a vacuum, but this time I routed a hose extension through the wooden side panel and zip-tied it to the Z-axis. It took a while, but finally I have a setup that's truly set it and forget it. And that's it for today. I don't know if you thought this was as interesting as a CNC project, but for me this was a stepping stone to that end. Before moving on to materials like slate or aluminum, which can throw out some pretty nasty chips, I wanted to make sure that I wouldn't be making a hazardous mess at home. I want to thank you all very much for watching, and if you have any suggestions for improvements, please leave them in the comments down below. I'll see you in a couple weeks, Internet.